Good evening, and once again welcome to my YouTube channel, Pearson and Excel International Maths by Mr. Kamoto. And today I want us to study something on Pure Mathematics 2 and page 13 concerning mathematical proof. And of course, we need to understand that a proof is a logical and structured argument to show that a mathematical statement or conjecture is always true. And a mathematical proof usually starts with previously established mathematical facts. You have to have facts, you have to have known facts, and then works through a series of logical steps. Facts go through a series of logical steps. This series of logical steps, of course, analyzing the facts. And the final step in a proof is a statement of what has been proven. A statement of proof. A statement of proof. A statement of proof. Well, a mathematical proof needs to show that something is true in every kind of way. And we are told that down there, I wish you would read the bold statement down there, that in a mathematical proof, you must state any information or assumptions you are using. Number 2, you must show every step of your proof clearly. And number 3, you must make sure that every step follows logically from the previous step. And number 4, you must make sure that you covered all possible cases. And number 5, write a statement of proof at the end of your working. This is just what I'm reading through, that in a mathematical proof you must do the following: state any information, show every step, and make sure that every step follows logically from the previous one. Make sure you have covered all possible cases, and write a statement of proof at the end of your working. And I would wish now to explain something on page 14. You need to be able to prove results involving identities. Identities such as a plus b multiplied by a minus b. You need to prove that this is equals to a squared minus b squared, difference of two squares. And again on page 14, bold, to prove an identity, you should, let's just highlight that. To prove an identity, you should start with the expression on one side of the identity. 2, manipulate that expression algebraically until it matches the other side. And 4, or 3 rather, show every step of your algebraic working. And having done that, then you will have proven an identity. Let's talk about example 11 on page 14 so that we can understand exactly what we are saying. Example 11. In example 11, you're told, prove that bracket 3x plus 2 close open, x minus 5 close and open another one, x plus 7 is equals to 3x cubed plus 8x squared minus 10x minus 70. I mean, if you look at it, it's just a bracket which has been expanded. And I would want to take, for example, something like 3x plus 2, multiply it out using FOIL x minus 5. And this one should take us somewhere. 3x squared, this is 3x squared, minus 15x plus 2x minus 10. Collect the like terms and you're going to have 3x squared minus 13x minus 10. This now 3x squared minus 13x minus 10 is the one we need to multiply with the last bracket, x plus 10. And so to speak, this is just going to be simple. 3x squared times x going to be 3x cubed. And then 3x squared times 7 plus 21x squared. And we are through with this. Go to the other one. Minus 13x times x minus 13x squared. Minus 13x times 7. Let me talk about 13 times 7, which is 91, which is going to be minus 91x. And you are through with minus 13x. Minus 10 times x, minus 10x, and minus 70. Collecting the like terms now, we have 3x cubed, 21x squared minus 13x squared. 21 minus 13 is plus 8x squared. And then x minus 91x minus 91x minus 10x, which is going to be negative. And by the way, we need to prove that this bracket is supposed to be 3x cubed plus 8x squared minus 101x. 100, not 10x. Please make that correction. And let's collect the like terms on x. Minus 91 minus 10x minus 101x. You can see how they match. And of course the constant minus 70. Hence shown, because this is just what we are supposed to prove. So you can see now the left hand side is equals to, the left hand side is exactly equals to the right hand side, and this is what our intention was. All right.